Welcome to the channel H2O, the A to Z of chemistry. I hope you all JEE mains and NEET aspirants know that the National Testing Agency or NTA, this has launched an app called as the National Test Abhyas, where it is giving several mock tests for the preparation of your examination. But due to the paucity of time, and there are so many mock tests given over there that you are not able to attempt all of them. In fact, you're not able to attempt more than about 10-20 mock tests if you are really attempting them also. Now, so that we can help you for your preparation and you can have a glimpse of the questions which are put in this mock test, what we are going to do is we are going to show you a few of the NTA mock test questions, chapter wise or topic wise. And the topic that we will be discussing today is going to be Group 17 P block elements. We have scanned all these question papers. The questions which we found to be different or the questions which we found they were very, very important for you is what we have put up in our lecture. So today I'm going to be discussing with you 20 questions from the group 17 P block elements or halogen family so that you can improve your scoring in your JEE mains and NEET examination. I hope these questions will be really very helpful to you because you will be finding that there are going to be many similar questions which will be there in the JEE mains previous year examination questions and the NEET previous year examination question, even in the JEE advanced examination questions. So this is going to be something that is going to be very, very helpful for you people. But before I begin, one very important advice for the whole of inorganic chemistry, because we are talking about inorganic chemistry today, please do read your NCERT textbook very well. Read it at least 5-6 times, write down all the questions 5-6 times so that you can excel in your examination. This is going to be just topping of your cake. All right. So I am Dr. Ritu Johar, your educator from the channel, and I hope you're going to enjoy this learning with me and you're going to really benefit from this lecture. So let us begin the learning. So I begin with question number 1. Question number 1 is iodine is solid and sublimes at ordinary temperature. This is because of weak iodine-iodine bond, strong iodine-iodine bond, lone pair repulsions, weak van der Waals forces between the iodine molecules. Now I will be showing you first of all one question and I would like you to pause the lecture over here and attempt your answer and then look at the solution because this way it will be really very beneficial to you. So now pause the lecture, think of your answer and then look at the solution. So now if you've done that, let us understand over here. First of all, very importantly, what you can understand is that iodine is a solid and this is such a solid that it is subliming at ordinary temperature. This means it is getting converted into a gas. So we are heating iodine and it is getting quickly converted into a gas. What this means is that there are very weak van der Waals forces of attraction present between the iodine molecules. So the correct option over here is going to be D choice. Now please do remember this is the question that I've chosen as question number 1 because with this I am just introducing you to the halogen family. So the halogen family is going to consist of first of all fluorine. Fluorine is going to be F2, a diatomic gas, and it is a pale yellow gas. The next element is going to be chlorine. Chlorine is again a diatomic gas and this is going to be a greenish yellow gas. All these colors, they are important for you people to remember. Okay. And then we have bromine, which is a reddish brown color liquid. And then we have iodine, which is a dark violet solid. What I have not written here from the halogen family is astatine, which is a radioactive element. So you can just add it to your notes. Okay. So these are the 5 elements of the halogen family: fluorine, chlorine, bromine, iodine, and astatine, which is a radioactive element. Fluorine, chlorine, they are gases. Bromine is a liquid and iodine is a solid. and iodine is a solid which sublimes at ordinary temperature, which means that the van der Waals forces of attraction between the molecules is very weak. That is why it is quickly getting converted into a gas at ordinary temperature. So now the next question that I'm going to be putting to you people is going to be related to the atomic and the physical properties for the group 17 elements, the various trends that we see for electron affinity, ionization, enthalpy, atomic size, etc. So the question I have chosen over here for you people, the question is the highest electron affinity is shown by the fluoride ion, the chloride ion, the sodium ion or the lithium ion. So please first of all pause the lecture, answer the question, and then we will be talking about it. So if you people have done that, well, the correct answer to this question is going to be D choice. Okay, first of all, what is electron affinity? It is the energy which is going to be released when an electron is added to the outermost shell of the isolated gaseous atom or ion. Okay, now here what you can look is that these are not atoms, these are ions. I hope you all remember the electron affinity trend as we move down in a group. Electron affinity generally is going to decrease as we are going to move down the group, because what will be happening? The size of the atom that increases, and as the size of the atom increases, the pull of the nucleus for the incoming electron is going to decrease, and therefore the electron affinity that decreases. But in case of fluorine atom and chlorine atom, I am saying fluorine atom and chlorine atom, please do be very careful over here, because in this question it is a fluoride ion and a chloride ion. So what I'm talking about is the fluorine atom and the chlorine atom. The fluorine atom, this is small in size, the chlorine atom is going to be slightly more. Therefore, when an electron is added to the fluorine atom, well, what will be happening is that the electron will be facing repulsions. Therefore, what we find is that the electron affinity of chlorine is greater than that of fluorine. Okay. Now, I will be showing you all those trends also to you just now. But in this question, what we have is a fluoride ion, a chloride ion, a sodium ion, and a lithium ion. All of these, they are having noble gas configuration, and you have to tell that which out of this will be having the most electron affinity for the incoming electron. So first of all, understand that these two, they are also having a noble gas configuration, and these two also having a noble gas configuration. Okay, so here how are you going to compare the electron affinity trend for them? So here just understand that this electron affinity is going to be directly proportional to the charge density, which is nuclear charge over the size of the atom or the ions. Okay, so in case of the fluoride ion and the chloride ion, the nuclear charge is going to be minus, whereas in case of the sodium and the lithium ion, the nuclear charge is going to be positive. So obviously a positive value is going to be greater than a negative value. So the electron affinity is going to be more for the sodium and the lithium ions in comparison to the fluoride and the chloride ions. Okay, I hope first of all this is clear. Okay, now out of lithium and sodium ions, which one will be having a greater electron affinity? Well, it will be lithium. Why lithium ion? Because the electron can reach nearer the nucleus and the energy released would be the highest because of the small size of the lithium ion. Okay, so here the highest electron affinity is going to be shown by the lithium ion. Perfectly fine. So this is something more than you people already know from the various trends, but I would like to quickly revise with you all the trends that we have over here for the group 17 atomic and physical properties. So first of all, we have those trends which are going to be increasing down the group from fluorine to iodine. The atomic and the ionic size, they are going to increase. The bond length is going to increase. Which bond length? The fluorine-fluorine atom bond length in the fluorine molecule to comparing it in the iodine molecule. The atomic and the ionic sizes, they are increasing, and the bond length will also be increasing. Now what is going to decrease? Well, from fluorine to iodine, the values that we will be seeing decreasing are going to be the ionization enthalpy values. They will be decreasing down the group. The electronegativity values, they will be decreasing down the group. The bond energy, because the bond length is increasing, so the energy required to break the bond is going to be less. So the bond energy is going to be decreasing, and the oxidizing power is also going to be decreasing down the group. So which is going to be the strongest oxidizing agent out of all these? Well, it is going to be fluorine. So do remember this. This is going to be very important for you people to remember these trends. Okay. Now the next thing is electron gain enthalpy order, which I've already told you that chlorine will be having electron gain enthalpy greater than that of fluorine. Otherwise, what we find is that going down the group, the electron affinity values, they decrease. So chlorine, fluorine, bromine, and iodine, this is going to be the order for the electron gain enthalpy or electron affinity. And then one more important order that you people have to remember is going to be the order for the bond dissociation enthalpy. So the bond dissociation enthalpy value is highest for chlorine, then bromine, then fluorine, and then iodine. Please do remember this very importantly. The next question coming up on your screen, match the following: ICl2 negative, BrF2 positive, ClF4 negative, AlCl4 negative, and you have to match it up with the various geometries that we have. Okay, now first of all, understand the importance of this question. First of all, here what you can see is that these are interhalogen ions. So from your NCERT textbook, group number 17, the interhalogen compounds, they are very important for you people. Okay, and here what is being tested over here is the various shape of the ions. You can be asked the various shape of the molecules, the interhalogen molecules also. So you should have a thorough understanding of your lectures of chemical bonding, the VSEPR theory, the hybridization, the geometry, the shape of the molecules. In case you have any doubts related to this, we have already uploaded a complete detailed learning on chemical bonding lectures. So wherever you have a doubt, you can just go to the playlist on chemical bonding and have a look at those lectures and revise and brush up your concepts. Here, excuse me, I have a bad throat, so you will be just able to cope up with that. All right. So now you have to again just pause the lecture, attempt the question, and then look at the solution. So if you've done that, well, the correct answer to this question is C choice, and the various shapes according to the C choice that we have is that ICl2 negative has a linear shape, BrF2 positive will be having an angular shape, ClF4 negative will be having a square planar shape, and AlCl4 negative will be having a tetrahedral shape. Now, if you people have done it correctly, very good. In case you haven't, do not worry, because here I'm going to share with you people a trick to solve this question. In fact, if you look at my lectures on chemical bonding, there is a lecture on trick to find out the hybridization of various molecules, which is, I think, lecture number 29 or 30 from my 40 lecture playlist that I've already uploaded on chemical bonding. It's a detailed playlist. You can find each and every concept over there. There I have put 2 tricks to calculate hybridization. I am discussing with you one out of those 2. Okay, so let us see how we are going to use the trick and find out the shape of the molecules. So the trick to find out the shape of the molecules is going to be its steric number. Now, what is steric number? The number of atoms bonded to a central atom of a molecule, or it can be an ion, plus the number of lone pairs attached to the central atom. This is going to be its steric number. Okay. Now, this is used in the VSEPR theory to determine the molecular geometry of a molecule. What is VSEPR theory? Again, you can have a look at my lectures on chemical bonding. Now, the calculation of the steric number, how are we going to do that? The trick that I'm using over here is that the steric number, this is going to be equal to n by 8, which will be equal to q plus r by 2. Now, what is n, what is q, and what is r? Well, n is the number of valence electrons of all atoms in the molecule or the ion. Please do remember all atom valence shell electrons. You have to count them. To that, if it is going to be a negative ion, just add the number of negative charges, and if it is a positive ion, add that, subtract that number of positive charges from it. The sum total of all this is going to be equal to n. Okay, and what you have to do is n by 8. When you will be doing n by 8, you will be getting the value of the steric number. Okay, and now what is Q over here? Well, Q is going to be the number of bonded pair of electrons, and what is R? This is the number of unshared electrons on the central atom, and if you're going to divide this by 2, well, this will be giving you the lone pair of electrons. So the number of bonded pair of electrons plus the number of shared pair of electrons is going to be, the bonded pair of electrons and the lone pair of electrons, the sum total of this two is going to be again equal to the steric number, and from the steric number you can tell the hybridization of the molecule. For example, if the steric number is 4, it is going to be sp3 hybridization. Now if the steric number is 2, it will be sp. If the steric number is 3, it will be sp2. Again, you can watch all of this in a detailed understanding in my lecture on the tricks on hybridization. That will be very, very helpful if you do not have a thorough understanding by this time. So let us do one example from the 4 choices that we have. We will be choosing now over here ICl2 negative. So first of all, you have the formula steric number equal to n by 8 equal to Q plus R by 2. So the first step is finding out n. So what you will be doing is totaling the number of valence shell electrons for all the atoms. Iodine is 7, chlorine 2 atoms, 2 into 7, and plus 1 for the negative charge. So n is going to be equal to 22. Divide this 22 by 8. So what you will be getting as the quotient is 2. 8 into 2 is 16, and the remainder will be 6. 6 divided by 2 will be giving us 3. Okay, so the steric number is going to be equal to Q plus R by 2. So this will be 5. Now steric number 5 means that there will be 5 orbitals which will be participating in hybridization. When 5 orbitals are going to be participating in hybridization, the hybridization is going to be sp3d. And when we have sp3d hybridization, the geometry that we have is going to be trigonal bipyramidal geometry. There will be 3 orbitals which will be arranged on the equatorial axis and 2 orbitals which will be arranged on the axial axis. And here what you have to remember when we are talking about the shape of the molecule, the lone pairs, they always prefer to remain on the equatorial axis, and it is going to be the bonded pair which will be there on the axial axis. Okay, so we find that the iodine chlorine bond to be on the axial axis, and hence the shape of the molecule, because when we are seeing the shape, we do not talk about the lone pair of electrons, we see so what all are the atoms, how they are arranged. Geometry, this tells us the arrangement of all the orbitals, but when we are talking about the shape, we talk about only how the atoms they are arranged. So the shape of the ICl2 negative ion is going to be a linear shape. All the 3 atoms, they are in one line. So this is how you will be using the same concept for the rest of the ions as well. So now you can look at all the structures that I have. We have ICl2 negative, which will be according to the formula we've just now calculated. Hybridization is sp3d, and the shape which came up to be a linear shape. Then the next one we had was BrF2 positive, where we found out from the same formula hybridization came up to be sp3. Now you can just try it once again and check whether I have done it correctly or not. The shape is going to come as an angular shape because there were 4 orbitals, but 2 of them they were occupied by the lone pair. So when we are talking about the shape, we do not talk about the lone pair, and we see the shape of the arrangement of the atoms. So the atoms, they are forming an angular shape or a bend shape or a V shape. This is just similar to the shape of the water molecule. The next we have is ClF4 negative. Here you will be finding out that the hybridization will come up as sp3d2, and sp3d2, there are going to be 4 bonds which will be arranged in one plane, and the 2 lone pair of electrons, they will be occupying the axial position over here. So to minimize the repulsion between the lone pair of electrons and the bonded pair of electrons, and the shape of the molecule, we will be having a square planar shape. The next one we are having is AlCl4 negative. Here the hybridization is going to be sp3. All the bonds, they are going to be, all the the steric number, this is going to be in accordance with the bonded pair of electrons. Therefore, the shape and the geometry is going to remain the same. It is going to be a tetrahedral geometry. Now, the next question, this is also a same type of question as I told you earlier. The set which has all the species planar, this is I3 negative carbon dioxide, XCF4, I2Cl6 and the various four choices they are. And in this question also, you have to do it the same way that we did the last question. So you can just pause the lecture here, again try your answer and then look at the correct answer. I will just be giving you the correct answer over here because I've already explained you the concept. Again, if you have any doubts, please feel free, put your doubts in the comment section. Definitely we will be responding you back. So if you've done it, well, the correct answer is going to be A choice. We have the structure of I3 negative to be a linear structure. So linear means it is going to be in one plane, obviously. Then we have carbon dioxide. Again, it is going to be a linear structure. XCF4 is going to be a planar structure, and I2Cl6, this is a dimer of ICl3, and this is also going to be a planar structure. So the correct option is going to be A. Now, in again all these, what you can see as far as the halogens they are concerned, you will be finding many interhalogen compound structures. So again, the structures of these interhalogen compounds, this is going to be very, very important for you people. So please do practice them very well. Now, as I'm talking about the interhalogen compounds, which means that is going to be a compound or an ion where we will be having just two halogen atoms. So for that, please just go back and look at your NCERT textbook. There are two sets of reactions that you have to learn for the interhalogen compounds. One is going to be the preparatory reactions and the second is going to be their hydrolysis. So both those reactions, they are also important. So please learn them. For example, if I give you just one example, that we have iodine reacting with fluorine. This is the preparation of the interhalogen compound. In equimolar quantities, what we will be getting, the compound is going to be IF. Okay, so you can just balance the reaction. But if it is going to be combining with 3 moles of F2, the compound that you will be getting is IF3. If it is going to be combining with 5 moles of F2, it will be IF5. And if it is going to be combining with 7 moles of F2, the compound that we will be getting is going to be IF7. Okay, so this way we get the interhalogen compounds by the combination of the two halogens in different proportions. So this is one thing that you have to remember, and the other is going to be the reactions where we will be seeing the reaction with water. So that is going to be again very important for you people. For example, again, if we have a halogen of the type XX dash, in this X is going to be a less electronegative halogen and X dash is going to be a more electronegative halogen. Just remember in this always, because it is just similar to a MX type of a halide. Okay, so we have the M to be a metal. And you all know that this is more electropositive and the halide ion, this will be electronegative. So similarly, when we will be having an interhalogen compound also, you will be seeing that the first part, which is a cation, although these are covalent compounds, but you can just make a similarity to the metal halides also. So we will be having the first X to be a less electronegative element and the X dash to be a more electronegative element, as you can see over here, IF7. So iodine is going to be less electronegative than fluorine. So this is how these compounds are. So when we will be reacting a XX dash with water, what you are going to get is HX dash plus HOX. Okay, so the more electronegative halogen will be making the hydrogen halide compound, right? So the mineral acid that we have, and HOX, this is the hypohalide compound. Okay, so this is what you have to remember for various things. These are the various hydrolysis reactions which are given in the NCERT textbook. So please do remember them very well. They all are going to be very, very important for you people, along with the structures that we have discussed in these questions. Okay. Now, the next question is again related to the concepts of chemical bonding. The correct decreasing order of bond angles is, and the four molecules that are given to us, they are ClF3, PF3, NF3, and BF3. So again, what you will have to do, you will have to find out the hybridization, the geometry, the shape of the molecules. Only then you will be able to predict the bond angles. So what is going to be the correct answer? Think. All right. So if you have thought of, let us quickly look at the correct solution over here. The correct answer to this question is going to be D choice. We have the highest bond angle in case of BF3. Then it is going to be NF3, PF3, and ClF3 is going to be the least angle. How do we explain this? Okay, so first of all, if you have to find out the hybridization for the four molecules, you will find that in ClF3 it will be Sp3d hybridization. In case of BF3 it is going to be Sp2. Then in case of PF3 and NF3, both of them will be having Sp3 hybridization. If I talk about why we have BF3 to be the largest angle, it is Sp2 hybridization. All the three are bonded pair of electrons, so each angle is going to be 120 degree. Okay, the other option we can have is that ClF, this angle, this can be an angle of 180 degree, and FClF, this should be an approximately 90 degree angle. Okay, because this is an axial bond and this is an equatorial bond, so this should be approximately 90 degree had this not been a lone pair. So either there are going to be two possibilities over here. If we are taking this to be 180 degree, then it should be first of all ClF3 and then BF3, but we do not have any of those choices over here. We are not having a single choice where we will be having first of all ClF3 and then BF3. So what has been asked to us in this question is this bond FClF. And if you look at this bond, well, there are two lone pair of electrons. So these two lone pair of electrons, they are going to repel the bonded pair of electrons away from it. And what we will be seeing, rather than this angle being 90 degree, it is going to be slightly less. The bonded pair of electrons, they will come closer and we will be seeing that this is going to be 86 degree. Okay, as far as these two they are concerned, both of them they have Sp3 hybridization. Both of them they have one lone pair of electrons, and then we have one Sp3 hybridization, sorry, the normal angle when all the four bonded pair are there, then we have the bond angle to be 109.5 degree, which we see in the case of methane. Okay, so these two they have to be somewhat near to that values. So what you can understand is that BF3, first of all, this will be the highest, and ClF3, this will be the lowest. Okay, so out of these options we have two of these possibilities, either B is going to be correct or it is D that will be correct. So only choices now PF3 and NF3, which one will be a greater bond angle. Okay, so now in case of NF3 we have nitrogen to be a small atom, okay, and phosphorus to be a larger atom. So the repulsions on phosphorus is going to be less, right, and the bonded pair of electrons they can come closer. So we will be finding that NF3 is going to be a larger bond angle than compared to PF3. So therefore the correct option is going to be BF3, then NF3, then PF3, and then ClF3. But I do not finish the question over here. This question is very important because there are other things which can be asked very frequently in the examination related to these two. Okay, what is can be asked? Let me show you that. The first thing that we have over here is that we have the bond angle comparison of NH3 and NF3. You have to explain what are these two values. So why in the case of NH3 and NF3 the bond values they are different when we have nitrogen to be the central atom, okay, or both of them they will be having three bonded pair of electrons and one lone pair. Why this value is less? So this value is less because fluorine is going to be more electronegative in comparison to nitrogen, whereas hydrogen is less electronegative in case of ammonia. So what is fluorine going to do? Well, fluorine is going to pull the bonded pair of electron towards itself. So nitrogen, this will be having a less electron density in case of NF3 than in comparison to the bond angles in case of NH3. So that is why we find that these The electron density of nitrogen, this is less, therefore the bonded pair of electrons, they can come closer, and the value of 107.8 degree in NH3 reduces to 101.9 degree in NF3. But now let us look at another set of values, and the set of values I have is for pH3 and PF3. The values that you can see in case of pH3 and PF3 are 93.6 degree and 96.3 degree. Again, here we have the same central atom phosphorus. We have hydrogen bonded to phosphorus and we have fluorine bonded to phosphorus. But what we can see is, surprisingly, here from NH3 to NF3, the values they had decreased, but in pH3 to PF3 the value they have increased. Now how do we explain this? This is another question which can be asked to you in the examination, and what is going to be the answer to that? Well, the answer is going to be back bonding. In case of PF3, there can back bonding take place from the lone pair of fluorine to phosphorus. And when there is going to be back bonding taking place, the electron density is going to again shift more towards the phosphorus side. And hence what do we find? When the electron density is going to be more, their repulsions between the bonded pair of electrons is going to be more, and therefore these bonded pair of electrons, they will be moving farther away. So that is why we see in case of pH3 and PF3, the value in PF3 is going to be slightly more. Okay, so please do remember these things very importantly for your examination. From NH3 to NF3, the values of the bond angle, they are decreasing because of increased electronegativity of fluorine. But from pH3 to PF3, we cannot use the same concept because over here we have seen back bonding take place, which does not take place in NF3 because of the absence of because of the absence of d orbitals in case of nitrogen, which are present in case of phosphorus. Okay. Now the next question that we have is that NaNO3 on heating, this gives us A plus B. A with HCl in presence of copper chloride, this will be giving us a compound C, which you can see this is going to be a gas, and along with that water is going to be formed. And you have to tell what is going to be the color of C and A. So here the correct answer is going to be B choice. The compound C is going to be green yellow color. So this is a green yellow color gas, and along with that the compound A that we have, this is going to be a colorless compound. Now how do I explain? How did I get this answer? If you have not got it correct, well, let us see what is going to be the explanation. So NaNO3 on heating, this gives us A and B. So you have to remember the heating of alkali metal nitrates, what is going to be the compound that is going to be formed. There are two kinds of products formed. One is going to be a product for all the alkali metal nitrates except lithium nitrate, and lithium nitrate is going to give a different type of compounds. As far as sodium nitrate and potassium nitrate, cesium nitrate and rubidium nitrate, they are concerned, when they will be heated, they will be giving us oxygen, and along with that the alkali metal nitrite, in case of sodium it will be sodium nitrate. Okay, what happens when we are going to heat lithium nitrate? This is going to be your study of the group 1 elements. Okay, so when we are going to heat lithium nitrate, the compound that you will be getting is going to be lithium oxide. Along with that you will be getting NO2 gas, which is a reddish brown color gas, and along with that oxygen, which is going to be a colorless gas. Okay, so as far as the rest of the alkali metal nitrates are concerned, you are going to get similar kind of product. Now I've already posted a lecture on heating of metal nitrates, what is going to be the product form. You can remember that in a very easy way. That lecture is available in my playlist on Inorganic Made Easy. So do watch that lecture. You will remember the products of the heating of the metal nitrates very easily with that lecture. Okay, so now NaNO3 is giving us O2 and NaO2. So this means our A is going to be oxygen, and this is a colorless gas. Okay, now the next part of the question is that A plus HCl, this in presence of copper chloride, this is giving again a gas, and along with that water is going to be formed. Okay, so A is oxygen, and oxygen plus HCl in presence of copper chloride, this gives us chlorine and water. This is one of the methods of preparation of chlorine called as the Deacon's process. Okay, there are two more processes which are going to be very important for the preparation of chlorine. One is going to be the electrolysis of aqueous sodium chloride, that is going to be important. Okay, and the other is going to be the Weldon's process. Both of them, they are given in the NCERT textbook. I want you to read them too. They are also equally important. Okay, this reaction is also very important, and those two also, they are going to be very, very important. So please do look them up from the NCERT textbook. So here we have oxygen plus HCl in presence of copper chloride giving us chlorine, and along with that water, the Deacon's process. And chlorine, I have told you at the start of the lecture also, please do remember the color. It is going to be a greenish yellow colored gas. Okay, so we have the C to be a greenish yellow colored gas and A to be a colorless gas. Perfectly fine. The option that came out to was B. So the colors of C and A, they are going to be green, yellow and colorless. Okay. Now the next question that we have is the change in oxidation state of iodine when excess of chlorine water is added to an iodide salt is going to be dash. This is a numeric type of question which is asked in the JEE mains examination, and this is again one of the properties that we have for chlorine. Okay, so now what is going to be the answer? Well, the correct answer is going to be 6. Now, how did we get this answer? Let us look at the solution. We have, first of all, a iodide salt. So the iodide salt that we have is Ki. Ki is to be reacted with chlorine water, and chlorine water means chlorine plus water. Okay, so we have first of all Ki reacting with chlorine to form KCl and I2. Chlorine, I2 and water, when they are going to be combining, what we will be getting is HCl plus HiO3, and here the change in oxidation state of iodine is going to take place. We will be first of all having the iodine over here is going to be plus 5, all right, oxidation state, and in case of Ki it was -1 oxidation state. So 5 minus -1 is going to be 6. So this is a change of 6 oxidation state for iodine in this reaction. Okay, so this is one of the very important oxidizing reactions of chlorine, and there are many more reactions given in your NCERT textbook. For example, chlorine oxidizes ferrous sulfate to ferric sulfate, sodium sulfite to sodium sulfate, moist sulfur dioxide to H2SO4. So please do remember these reactions also. They are equally important. So this way, any reaction can be asked from the oxidizing properties. My motto is that you revise all these reactions. Okay, so this is very important. Now the next question, again, this is one of the very important reactions of chlorine. So please do learn this two reactions which have been asked in this question very well. What does the question say? First of all, let us look at that. In the following reaction, X and Y, they are respectively. First reaction we have is NaOH, hot and concentrating, reacting with chlorine to form X and the side products. And the next question we have calcium hydroxide dry plus chlorine forming Y and the side products, and you have to tell what is going to be X and Y. Both these reactions, they are really, really very important for you people, so do not miss these reactions. The correct answer over here is going to be B, and let me give you the reactions. First of all, when hot and concentrated NaOH, this is going to be reacting with chlorine, what we will be getting is NaCl, NaClO3 plus water. And when calcium hydroxide will be reacting with chlorine, what we will be getting is CaOCl2. This is bleaching powder formula, I hope you all remember. And this is now calcium chloride and water. So now how will you remember these reactions is what I want to teach you over here in this lecture. first of all, why I'm going to give you a trick to remember these reactions of NaOH is because this is not a reaction which has been asked only in the NTA mock test, but in fact, this is a reaction which has been repeatedly asked in the JEE mains examination, the JEE advanced examination, the Neet examination. So this is a very, very important reaction for you people to remember. Okay. All right, so how are we going to learn this? Let us understand this. We have two types of reactions when we are going to talk about the reaction of chlorine with NaOH. One, when NaOH is going to be dilute and cold, and the other is going to be when NaOH is going to be hot and concentrated. So let us look at the two types one by one. First of all, we will be learning the reaction of NaOH with chlorine when NaOH is going to be dilute and cold. So here first thing that you have to remember is that when we say NaOH, this means that this is going to be the aqueous solution. And when it is aqueous solution, what does this mean? Along with NaOH and chlorine, we also have water in this reaction. Okay, so the first two compounds that we will be reacting is going to be chlorine and water. Okay, so when chlorine and water they are going to react, we have Cl2. So can we write Cl2 as Cl bond Cl? Okay, and here what we will be seeing is that in case of chlorine, this is a non-polar molecule, but in a non-polar molecule also, they can develop an instantaneous dipole. I hope you all agree that there can be one moment when the sum of the negative charge is going to be more on one side and the positive charge obviously will be on the other side. So what we will be seeing is that, let us say, on this one, we have an instantaneous dipole. This chlorine has a partial negative charge and this chlorine, this has a partial positive charge. Okay, so when this chlorine has a partial negative charge and this breaks, you understand that this will be reacting with H positive of water and the Cl positive will be reacting with OH negative ions of water. And the product that will be formed is going to be HCl and it will be HOCl. So this is very easy for you people to remember that give one chlorine a negative charge and give the other chlorine the positive charge, and water is going to ionize and H ions and OH ions. So the positive negative combine to form the product. So this product I think is going to be easy for you people to remember. Chlorine plus water will give us HCl and HOCl, that is hypochlorous acid. Okay, now further what we are going to do is now react these two compounds with NaOH one by one, and that should be easy now. So when HCl and NaOH they are going to combine, again we will have H positive and here this will be OH negative, so this will be giving us water, and here this is Cl negative and Na positive, so this will be giving us NaCl. Similarly, when we have HOCl and reacting with NaOH, the two compounds that we will be getting is NaOCl and water. Right? Easy enough, I think. And then what you have to do is going to be simply compiling the products of the reaction and you will be getting the product. I will be just now showing you that product also in the final steps. Okay. Now let us move on to the other side when we have chlorine reacting again with aqueous NaOH, but this time the NaOH is going to be hot and concentrated. So what is going to be the difference? Let us see over here. Again, this will be chlorine plus NaOH plus water. Again, what we will be reacting first of all is going to be chlorine and water. So what is the product form? We have chlorine plus water forming HCl and HOCl. But now this HOCl, you can understand that this has to react with NaOH, and this NaOH, or you can say that the temperature of the solution is going to be higher than compared to over here. So this is a hot solution. So the temperature is high, and what you have to remember over here is when the temperature is high, this HOCl on heating, this gives us HClO3 and along with that HCl. This is a disproportionation reaction of the oxoacids. When the oxoacid, they have the central atom to be having the oxidation state less than maximum. When it is going to be less than maximum, they are always going to show a disproportionation reaction. And in case of the disproportionation reaction of HOCl, the compounds that will be formed is HClO3, and along with that HCl will be formed. Okay. So this is the ic acid of the ic oxoacid, and along with that HCl, where chlorine is going to be in the -1 oxidation state. So this you will have to remember. Okay. And then it is going to be again very easy. HCl plus NaOH will be giving us NaCl plus water, and HClO3 plus NaOH will be giving us NaClO3 plus water. So the two reactions, they are going to be chlorine plus NaOH aqueous. They will be giving us NaCl, NaOHCl and water, and whereas in the other case it will be NaCl, NaClO3 plus water. I hope now this is clear, and if you just compile all of these together, you will find that the reactions also you will be able to balance very easily in the various steps. Okay. So these are the two products that will be formed. NaCl and water is going to be same for both of them. In the dilute case, it will be NaOCl, and in the concentrated case, it will be NaClO3. So now these are the two reactions that we have, but the next one is going to be for calcium hydroxide plus chlorine. Okay, so here what you have to remember is that these reactions are also similar to NaOH. All of them, they are alkalis. In fact, the reaction that we have done for NaOH, you can also do the same reaction if you are asked lithium hydroxide, you are asked potassium hydroxide, you are asked cesium hydroxide, you are asked rubidium hydroxide. All of them, they are alkalis. Similarly, you will be finding that the products, they are going to be quite similar when you will be reacting these with calcium hydroxide. You will be doing that with strontium hydroxide. You do that with barium hydroxide too. So these reactions, they are going to be similar, and all of them, they are important. That is why I am taking some time to make you remember these. Okay. So in this case, the product that will be formed is going to be calcium chloride, calcium OCl2. This is the sorry, formula for bleaching powder, and along with that water is formed. So how is this similar over here? You can just correlate this to this reaction of NaOH when dilute and cold. NaOH is reacting with chlorine. Okay, so when Na and chlorine react, they form NaCl, and when calcium and chlorine will be reacting, what will be the compound from calcium chloride, because it has +2 oxidation state, right? Then we, instead of calcium hydroxide, now the second product was NaOCl. So now again the product will be same, calcium OCl twice, because again calcium is in the +2 oxidation state. You will be doing the same formula, and along with that water will be formed. So I hope now you can correlate these two reactions, and you now know what are going to be the products that will be formed. Okay, so this is the reaction of dry slaked lime with chlorine giving us bleaching powder. This is going to be very important, and if somebody asks you the correct formula or the correct composition of bleaching powder, it is just not this calcium oxychloride. Okay, what is going to be the correct composition? When we have bleaching powder along with calcium uh, oxychloride, there is also some residue of, there will be some calcium chloride also will be formed, so that will be also present. Some of the unreacted slaked lime will also be present, and along with that water molecules as water of crystallization, they will also be present, 2 of them. Okay, so this is going to be the correct composition of bleaching powder that we have. So this is also one type of question that is asked, so this will be also important for you people. Okay. Now the next question that we have is that bleaching powder contains a salt of an oxoacid, and one of its components, the anhydride of that acid, is Cl2O, Cl2O7, ClO2, Cl2O6. Well, the correct answer in this case is going to be A choice, Cl2O. Now, how do I come to this answer? First of all, now you know the bleaching powder, we are getting it from which oxoacid, right? So the oxoacid was HOCl. I hope you all remember now that, because you have seen the whole reaction, what we found the products was the HCl and along with that HOCl when we react chlorine with water. Okay. And then further this is going to react with calcium hydroxide to give us calcium chloride. And HOCl is going to also react with calcium hydroxide to give us calcium oxychloride. Okay, so these are the two products. So from which oxo acid we have got the bleaching powder? It is from HOCl. Now what is asked to us is the anhydride of that acid. So what do we mean by anhydride? We have to remove all water that is possible from the oxo acid, and the compound that we will be getting is called as the anhydride of that acid. Okay, so we have to heat this and we have to dehydrate it, remove water from it. So when we have to remove water from HOCl, so water is going to be H2O. So for this you require 2 hydrogen. So we just multiply that by 2. So we will be taking 2 HOCls. Okay. And from that simply remove 2 hydrogen and 1 oxygen. So what you will be getting is Cl2O. Very simple. So the anhydride of HOCl is going to be Cl2O. Okay. I hope now this one is going to be easy for you. Okay. So I hope you are learning a lot from this lecture. There are so many small little things that you are learning and which can be asked very differently in the examination, but you know the concepts, so obviously you're going to do well. Now the next question we have is again a similar one to sodium hydroxide and calcium hydroxide, but in this case the alkali that we have is barium hydroxide. So chlorine plus barium hydroxide, this reacts to give us X plus calcium chloride plus water. Then X plus H2SO4, this will be giving us Y plus barium sulfate, and Y, when we are going to heat it at a temperature greater than 365 Kelvin, will be giving us Z plus water plus oxygen. So how are you going to do it? Well, at least you can do first reaction very easily because you now know how to do the reaction of NaOH calcium hydroxide with chlorine. So if you do that, well, you will be asking me the first question. The dilute concentrated is not given over here. So what are we going to do as the product? All right. So let us write two products that are going to be formed. If it is going to be dilute, we can say that the compound that will be formed is BaCl2O twice, BaOCl2. Okay. And in the other case, it will be BaOCl3 whole twice. So this is the two products that will be formed. So this and be the two X that we have. Okay. Now when X is going to react with H2SO4, it is going to be a displacement reaction. We are going to see that barium sulfate is formed. So it is going to be this or this reacting with hydrogen. So when it is going to be H positive with this, it will be HOCl. And when it will be H positive with this one, it will be HClO3. So these are the two possibilities. Now can you check whether out of these two both are present or only one? Well, you can see over here that we have out of the options HOCl and HClO3 only HClO3. So the two possibilities that we are having is B and C. I hope now this is clear. You can reach up to this step with the reactions that we have already learned. So let me just write them down for you. So I hope you now understand. So the next one you have to obviously remember that when we have HClO3, this we are heating. So this, when we are going to heat it, well, if you're going to remove all the water from it, what will be the anhydride that will be formed? Let me just tell you. Okay, so when we have, okay, sorry, we have HClO3. When you're going to heat it, if you're going to remove all the water, you will have to again multiply this by twice. Okay, so what you will be getting is Cl2, and this is 6, so it will be Cl2O5. This is the anhydride that is going to be formed. But again, you can see it is either ClO2 or it is either ClO7 over here as the choices. So this means that you are actually further heating this ClO2, and when you are going to further heat it, the compound that will be formed is going to be that oxygen also can go out of it. And when oxygen is also going to go out of it, well, the compound that you will be forming is going to be ClO2, and along with that oxygen. It will not be going into the higher oxidation state, it will be going up to a lower oxidation state. Okay, so the product that will be formed is going to be B choice, HClO3 and ClO2. So this is how you can remember these reactions. Now the reaction again, next one is also similar one that we have just now done. A greenish yellow gas. This reacts with an alkali to form a halate, which can be used in fireworks and safety matches. The gas and the halate ion, they are respectively. The gases can be the gas can be bromine, chlorine, iodine, and chlorine, and the halate ions KBRO3, KClO3, NaIO3, and KClO. Okay, so you have to choose which is going to be the correct option. Okay, so the correct option over here is going to be B choice. The gas is going to be chlorine. Why? Because this is a greenish yellow gas. So we know out of all these, chlorine is a greenish yellow gas, whereas reddish brown liquid is going to be bromine and iodine is going to be a violet solid. So they are going to be ignored. Okay, so now this is going to react with an alkali. So this can react with KOH, and this will be forming KClO3, KCl, and water. Okay, so we are going to have the halide ion to be KClO3. Okay, so I hope now this one is easy, not difficult. Now the next question is, the incorrect match is COCl2 is phosphine, SO2Cl2 is thionyl chloride, ClCH2CH2 SCH2CH2Cl, this is mustard gas, and H2SO5, this is Karos acid. Okay, so the correct option over here, well, which means that the incorrect formula and the compound combination is going to be B choice. Well, SO2Cl2 is called as sulfuryl chloride, whereas SOCl2 is thionyl chloride. So do remember this very important difference over here. And how do we find the mention of SO2Cl2 in the study of the halogens? Well, it is going to be that sulfur dioxide reacts with chlorine to form sulfuryl chloride. So it will be SO2Cl2 formed over here as far as your reaction related to the formation of sulfuryl chloride in the study of group 17 elements is concerned. All right, Karos acid is something that you will be studying in the study of group 16 elements. The above two, not above two, A and C, these are two poisonous gases which are formed from chlorine. So they are finding a mention in the uses of chlorine in the NCERT textbook. Plus along with this, there is one more name mentioned in the NCERT textbook. The three poisonous gases we get from chlorine, they are phosphine, mustard gas, and the third one is going to be tear gas. So please do remember tear gas also. We have CCl3NO2, that is called as tear gas, and the name for this is chloropicrin. Okay, so this is chloropicrin. So this is also something that you people have to remember very importantly. So the next question we have is that select the nature or the type of the redox change in the following reaction. Cl2 forming ClO negative plus Cl negative. This is a disproportionation reaction, intramolecular or intermolecular redox reaction, or none of the above. So you should have a clear understanding of what these three mean, and then only you will be able to choose the correct option. So first of all, you choose and then we talk about it. So well, the correct option for this question is going to be A choice. This is a disproportionation reaction. Now what is a disproportionation reaction? Well, disproportionation reaction is going to be that reaction in which the same substance is going to be oxidized as well as reduced. So here when we say Cl2, this is in the elemental state. So it is going to be having zero oxidation state. In ClO negative, the oxidation state of chlorine is going to be +1, and in Cl negative, it is going to be -1 oxidation state. All right. So here what is happening? Chlorine is going into the +1 oxidation state, is getting oxidized. It is going in the -1 oxidation state, it is getting reduced. So the same substance is getting oxidized as well as reduced. It is called as a disproportionation reaction. But you should have an understanding of what we mean by intramolecular redox reaction and intermolecular redox reaction as well. So the intramolecular redox change is going to be the one in which one element of a compound is going to be oxidized and the other element is going to be reduced. Whereas in the intermolecular redox reaction, we will be having two reactants. One of the reactants will be getting oxidized and the other will be getting reduced. But this is going to be a disproportionation reaction. Now the next question is that ClO2, this is an anhydride of HClO2, HClO3, or it is a mixed anhydride of two acids, that is HClO2 and HClO3, or of HClO3 and HClO4. So just think about your choice and then let us discuss about it. So the correct answer to this question is going to be C choice. And how do we come to know is that ClO2, when this reacts with KOH, we find that this is forming KClO2, KClO3 and water. Okay, so from this it is an indication that ClO2, this is a mixed anhydride of HClO2 and HClO3. But well, one point is that this reaction is important for you people to remember. But the other is that you can solve this question or questions of this type very easily if you have to tell that there an oxide is given to you and to have to tell that it is going to be an hydride of which oxo acid. Okay, so I'm going to give you a trick for that. Very easy one. So to find out whether this is first of all a mixed anhydride or a simple anhydride, what you have to do is just check the oxidation state of the central atom. For example, in ClO2, the oxidation state is going to be +4. Okay, and the other thing that you have to see is that the central atom, this is of which group. For example, when we talk about chlorine, this is going to be a group 17 element. Okay, so what this means is that the group number is odd and the oxidation state is even. The group number is odd, the oxidation state is even, it will be a mixed anhydride. Similarly, if there is going to be another example of an oxide where the group number is even and the oxidation state is odd, then also it will be a mixed anhydride. If it will be a simple anhydride, the oxidation state and the group number both will be even or both will be odd. Okay, so this is how you can identify. First of all, it will be a mixed anhydride or a simple anhydride. If it is a simple anhydride, for example, I talk about carbon dioxide. Okay, so carbon dioxide, this is a simple anhydride because this is a group 14 element and the oxidation state over here is going to be +4, so both are even. Okay, so this is a simple anhydride. So remember that the oxo acid it will be forming will be having the same oxidation state of the central atom. So here the it is going to be H2CO3. Okay, so the oxo acid for carbon dioxide is going to be H2CO3 carbonic acid. So again, here you will be finding that the oxidation state will be same. But in case oxide, this is the mixed anhydride, then what are you going to do to find out what acids it is going to be formed from? Well, very simply do 1 + 1 and -1 oxidation state. For example, when we do for chlorine. So chlorine is +4. If you're going to do +1 for it, the oxidation state will be +5. And if you're going to do a -1 oxidation state, the oxidation state will come as +3. So just simply write the +3 oxo acid of chlorine and the +5 oxo acid of chlorine. So these are going to be the acids for which this is a mixed anhydride. Okay, so +3 oxo acid is going to be HClO2 and +5 is going to be HClO3. So the correct option is therefore going to be C choice. Okay, so you can remember it this way. This is a very simple trick which is going to help you answer questions for any anhydride oxo acid question of this type. Number 15 is select the incorrect statement. The ionization enthalpy of helium, this is greater than that of neon. Chlorine has a greater electron affinity than fluorine. Order of acidity for the oxo acids of chlorine, HClO, will be having the maximum acidity, then HClO2, HClO3, and last will be HClO4. And there are 32 elements in period number 6. So as far as A choice is concerned, as we go down the group, the ionization enthalpies, they are going to decrease. So this is going to be correct. Chlorine, this has a greater affinity than fluorine. We've already discussed this. So this is also correct. The third option, well, this is the incorrect option. The order for the acidity for the oxo acids of chlorine is going to be that HClO4 is going to be the maximum acidic, and then HClO3, HClO2, and then HClO will be the least acidic. Okay, and as far as D choice is concerned, there are 32 elements in the period number 6. So I think this will not be very difficult for you. So the correct option over here is C choice. Okay, I'm going to give you a trick to remember this trends also for the oxo acids of chlorine. But just a moment, I have one more question related to this question. So question number 16, this says that identify the correct decreasing order of the acid strength of HClO, HBRO and HIO. And the correct option for this is going to be, well, it is going to be A choice. This HClO, this is the strongest acid, then HBRO, then HIO. So here you have two types of oxoacids. One where we have the central atom to be the same, the oxidation state is varying, and the other in this question number 16 where we have the central atom to be different. Okay, so I'm going to give you a trick to remember the acidic strength for these two types of oxoacids. So we will find out the acid strength of the oxoacids of halogens. First of all, we have acid strength of the oxoacids of the same halogen having different oxidation state. So we have HClO4, HClO3, HClO2 and HClO. So here the trick to predict the acidic strength is going to be that it is going to increase with the increase in the oxidation number of the halogen. So in HClO4, chlorine will be having +7 oxidation state. Here it will be +5. Here it is going to be +3 and here it is going to be +1. So the acidic strength is going to decrease from +1 to +1 oxidation, +7 to +1 oxidation state of chlorine. HClO4 will be the strongest and HClO will be the weakest. So this is the answer to your question number 15. Okay, and then we have the acid strength of the oxoacids of different halogens having the same oxidation state. So the halogen is going to be chlorine, bromine or iodine. So for example, we were HClO, HBRO, HIO, which was asked to you in question number 16. So here the trick is that the acid strength of the oxoacids having of the halogens having the same oxidation state is going to decrease with the decrease in the electronegativity of the central atom, or it is going to decrease with the increase in the atomic size. So as we are going to go down the group, the atomic size is going to increase, or you can say that the electronegativity is decreasing, and the acidic strength will also decrease with the decrease in electronegativity. Now why these two they are taking place according to this? Well, you can have a detailed understanding in my lecture on the oxoacids of halogens, which is available in the playlist on Inorganic Made Easy. Okay, so that list is that playlist I specifically put for those topics which are very frequently asked in the examination. Please do watch those lectures if you people can. Okay, but otherwise you can just remember these tricks to predict the acidic strength. So HClO will be having the highest acidity, then HBRO and then HIO. Now the next question is going to be similar oxoacid trend that you have to learn very importantly. Consider the following perhalate ions in the acidic medium: ClO4 negative, BrO4 negative, IO4 negative, and you have to arrange these in the decreasing order of the oxidizing power. So the correct option to this question is going to be D option. First of all, we have BrO4 negative, or you can say HBrO4 will be the strongest oxidizing agent, then IO4 negative and then ClO4 negative. So how do we come to know of this trend? Well, you come to know out of this trend from the standard reduction potentials of these perhalate ions. Okay, so we see the values of these reduction potentials, and what you have to understand here and remember is that more positive is going to be higher is going to be the value of the standard reduction potential, more is going to be the tendency of the perhalate ion to undergo reduction, and hence stronger will its be in oxidizing power. Okay, so you can see from these values BrO4 negative has the highest value, so this will be the strongest oxidizing agent, then IO4 negative and then ClO4 negative. So all these trends, the acidic strength, the oxidizing strength, then the thermal stability also for these oxoacids, they have been given in my lecture in detail, the oxoacids of halogens. So please do watch that for the thorough understanding and for your best performance in the examination. Now the next question that we have is that mercury on treatment with aqua regia, this gives mercuric nitrate, mercuric chloride, mercuric nitrite or mercurous chloride. So first of all, Well, the correct answer, let me tell you that what it is going to be. Well, it is going to be, the correct option is B choice. Okay, so this is going to be mercuric chloride that is going to be formed from mercury's reaction with aqua regia. Now, what is aqua regia? First of all, you should have a clear understanding, very importantly, that aqua regia, this is HNO3 and HCl in a ratio of 1:3. So 1 mole of HNO3 and 3 moles of HCl. This is called as aqua regia. Why do we use aqua regia? Generally, they are going to be the noble metals. Do remember that they do not react with HNO3. So to make the reaction possible, well, we add to that HCl, and then the reaction is going to be possible. So similarly over here also, when we are going to react mercury with HNO3 and HCl, it is going to be the reaction of mercury with HCl forming mercuric chloride. Along with that, NO and water is going to be formed. Okay, so this is what you have to remember very importantly for this reaction. Now the next question is, an example of a halide ore is galena, bauxite, cinnabar or cryolite. Now why I've chosen this question is because all these ores which are given in the group study or which is given in the metallurgical processes, these are very important. Very frequently the questions, they are coming in the examination from the ores. Okay, so this is something that is very simple to remember. So please do remember them very well. All right, so the correct option to this question is going to be, well, D choice. Cryolite is an halide ore. So let me give you the constitution of all these ores over here. So cryolite, this is going to be Na3Al(F6). So this is a halide ore. We have fluorine over here. Then we have galena to be PbS. So this is a sulfide ore, and cinnabar is mercuric sulfide. So this is also a sulfide ore. Whereas bauxite, this is an ore of aluminium. This is an oxide ore. It is Al2O3 2H2O. Okay, so now I'm going to give you a list of the halide ores that we have to study. So, well, the halide ores, first of all, we have cryolite, Na3Al(F6). Then we have fluorspar, which is calcium fluoride. Then we have fluorapatite, that is 3 calcium phosphate dot calcium fluoride. Okay, so 3 moles of calcium phosphate and 1 mole of calcium fluoride. This is called as fluorapatite. And then we have carnallite, which is KCl MgCl2 6H2O. So these are the halide ores that you should remember. Okay. Now the last question for today that I have for you is that the number of sp hybridized atoms in pseudo halogen cyanogen, this is R, and the correct answer, this is the numeric type of question. Well, the correct answer is going to be 4. There are 4 sp hybridized atoms in pseudo halogen cyanogen. So here, first of all, you should have a clear understanding what do we mean by a pseudo halogen and what is then the formula or cyanogen. Okay, so please do remember that this is not given in the NCERT textbook, but well, this is a question which has been asked in the NCERT, the NTA mock questions. So you should have some understanding of this topic as well. So first of all, let us understand what do we mean by pseudo halogens. Pseudo halogens, they are polyatomic analogues of halogens whose chemistry resembling that of the true halogens allows them to be used as a substitute for halogens in several classes of chemical compounds. For example, I give you a very common ion which is a pseudo halogen, that is going to be the cyanide ion. Okay, Cn negative. This is very much similar to the chloride ion, the bromide ion, the iodide ion, for example. You all know that chloride ion is going to form HCl. Similarly, the cyanide is going to form HCl. Okay, if I give you a similarity in the properties of the chloride ion and the cyanide ion, you all know the silver chloride, this is insoluble in water. Similarly, we have AgCN also insoluble in water. So we have these polyhalogens to be polyatomic compounds which are having properties similar to that of halogens. So they are called as pseudo halogens, not halogens, but well, properties similar to them. Okay, and now what is cyanogen? It is Cn whole twice. The structure for this you can see over here. We have a carbon-carbon single bond in the center, and each carbon is making a triple bond with nitrogen. So all of these 4 atoms, they are forming 2 sigma bonds and 2 pi bonds. So therefore 2 sigma bonds means they are going to be sp hybridized. So all the 4 atoms, they are sp hybridized. Therefore the answer is going to be 4. Okay, so I hope this is clear. So that would be all for this lecture. I hope you've gained a lot from this lecture. We have tried our level best to put up questions in such a way that you can cover and revise a lot many topics from the group 17 elements. You learn them with tricks and also some more concepts here and there which we have tried our level best to revise with you people. We will be putting up more lectures from this NTA mock test series. We are already putting up detailed courses from class 11 and class 12 topics of chemistry so that you can prepare very well for your JEE, mains, advanced and NEET examination. And also here and there we are putting up small little tricks for you people so that you can remember the reactions for inorganic chemistry easily. As I've already told you, the inorganic Made Easy playlist is already available with lot many lectures for making the inorganic chemistry study easy. Other also tricks we keep on putting here and there. So please do subscribe to the channel so that you get the notifications. Please click on the bell icon and do share it with your friends too. So see you again for the next lecture. Bye bye.